Hey all, welcome to our second day talking about volumes. And so we're going to keep going for chapter 6.2. We're going to talk about another type of revolved figure. If you look at this picture here, we're revolving it around the y-axis or a vertical line. So I want to show you an example of that in the notes. And then we will talk about the dreaded perpendicular cross sections, if you remember that from last year. So get yourself ready for notes and we're going to get started. So I wanted to show another problem that's one involving rotation around a vertical line, plus this one is involving no given numbers. We're using it to find a formula. So find the volume of a frustrum, which is this shape over here. And this is the way that Archimedes devised a lot of the different formula for volume and area. Obviously, his calculus looked very different from ours, but we're going to go through the same steps to try to find the formula for this volume. So the first thing that we want to use is recognize that this is a figure that is a line revolved around the y-axis. So we've got our line here, and we're revolving it around the y-axis between 2 points. We have a point here, which would be x is big R and 0. And then we have an upper bound here, which would be little r, and the y value is h. Going up here, h, and then over small r. If I draw on the rest of my axes, I can. Here we go. X and y. So we're going to be looking at, because we're revolving it around the y-axis, we're looking at little Riemann's rectangle like this. And so when that's revolved, it's the same disk. It's a little cylinder, which is coming from this same idea of volume. Volume is equal to pi, and then for this cylinder, r squared h. And in this case, this volume is pi x squared, because the radius is this x distance here. And then the h is dy, because it's a very small change on the y-axis. So that's the main difference, dy versus dx, when we're looking at discs and washers that are around vertical lines versus horizontal. Now, the next thing we want to do is figure out what this x is. This is going to be the function of the line, and we want this to be in terms of y. Just like our usual y, or f of x, we'd want in terms of x. The nice thing here is you'll recognize you want this to match this. Now, how do we figure out what this line is? Well, we have 2 points on it, so I'm just going to use point-slope form. And I'm going to say, well, I'm going to use this point as my point down here. So y minus 0, makes that easier, is equal to, and I'm going to use just the old slope formula from algebra, r minus 0 as our change in y over little r minus big R, x minus big R. So again, just using point slope form, obviously having that 0 is not going to make a difference either there or here. And then as we said earlier, we want to solve in terms of y. So I'm going to divide the coefficient over here and add r so that I can actually plug in x to this formula. And I'm going to have little r minus big R over h, y plus r is equal to x. Now, the integral I'm going to set up is going to be pi x squared, which is little r minus big R over h times y plus big R squared dy. And now, since you'll notice the variable we're using is y and y, that means our bounds also have to be in terms of y. So our lower bound for our y-axis, our lower bound here is 0, and it goes up to h. So our bounds are 0 to h, like that. And from here, it's going to be a problem. I would use u substitution just to make it a little bit easier. I would say, oh, u is equal to that large inner term over h, y plus r. I'll let you do the u substitution to keep this video from being too long. But once we plug it back in, we would end up with pi times 1/3 times u cubed, which would be little r minus big R over h y plus r cubed. And then we've got times another term, which would be the reciprocal h minus r, like so. And we're still going from our bounds of 0 to h. Now when we plug that in here, I'm going to pull out the constants just to make my life a little easier. So 1/3 pi times h over r minus big R. And then when I plug in my bounds to this inner term being cubed, I'm going to, when I plug in h here, these ones will just cancel out like this. So when I plug in h, I get r minus r plus r cubed. And when I plug in 0, multiplying this whole term by 0 just makes it 0. So then that's 0 plus big R cubed. And as we can see here, we're going to have some nice simplification. This will cancel out, so will this, and so it's r cubed minus big R cubed. And here's an algebra term that you might not remember, but it's going to be really helpful, is that we've got r minus big R and little r cubed minus big R cubed. And this is always going to be true, no matter what the powers are. If you have a difference, if you have a difference of powers divided by the same difference but without the powers, it will always end up like this. This will still be 1/3 pi h, and that difference will be r squared plus r big R plus r squared, like so. So basically what you're doing is you're dividing out by 1 degree, so r divided by 3, and then just counting down the powers, almost like the binomial theorem, except for it doesn't have any coefficients. And that is our formula for the volume of this figure. And if you want to Google it online, you will notice that the actual function, the actual formula, is exactly identical. All right, let's talk about cross sections. So a solid has its base on r. So we're using the same r as we did in our last lesson, where we have x and equals y and y equals x squared. Parallel cross sections that are perpendicular to the x-axis. So perpendicular to the x-axis means that we're dealing with the dx Riemann rectangle are equilateral triangles. Find the volume of the solid. So what I will always do is I'm always going to draw a picture of the cross section. So this is our dx. The length of this is the difference in between. So it's x minus x squared, because we're looking at this distance here, which is the line minus the parabola. And then since they say it's an equilateral triangle, I can sort of draw that up. We know this side, and this side are all equal. And there's our cross section. Now, we're going to always come back to these functions from geometry, which is we're looking at a prism, which is base times height, where our height in the case of these problems is always going to be either dx or dy, as we've seen up till now, depending on which axis it's perpendicular to. So in this case, dx. And the base here is the area of the cross section. So in this case, the area of this triangle, which is 1/2 base times height, which is the area of a triangle. So we already know what the base is of this triangle. We know that it's x minus x squared. Now the height's a little bit trickier, so I'm going to draw the height in here. So we've got this, And if we remember it's an equilateral triangle, we can use our Pythagorean theorem to say, well, if this side here is also x minus x squared, this would be, this little side here is 1/2 of that, and this here is root 3 over 2, like so. So our base is equal to 1/2 x minus x squared, and then the height is root 3 over 2 x minus x squared. And our final simplified version that I would do is root 3 over 4 times x minus x squared. Now, obviously, this base formula is going to be different. If it was a circle, we'd use pi r squared. If it was a semicircle, we'd use pi r squared divided by 2. If it was a square base, we would just use base times base. Whichever formula you use is going to be just based on the formula from geometry classes of your past. So now we have our volume, we have our base formula, which is root 3 over 4 and times x minus x squared dx, since we're using dx here, and we're just based on what's perpendicular to it. And then we'll use the bounds, in this case 0 to 1 from last lesson. It says find the volume. We can factor out the coefficient, root 3 over 4. And from there, this is a simple polynomial, x squared over 2 minus x cubed over 3. From 0 to 1, if we plug in 1, we get 1/2 minus 1/3. If we plug in 0, we just get 0. 1/2 minus 1/3 is 1/6. So this is root 3 over 4 times 1 over 6, which is root 3 over 24. If you have questions about anything, please make sure to nominate them in the form. Shoot me anything in the comments or set up a Zoom meeting. I'll talk to you later.